Hi guys, in today's video we will be looking at what is matrices and its inverse and its determinants. So we'll only be covering this as is limited time we have and a lot to cover, and in this topic is huge, so we can't cover everything in one video. So this is going to be just a video on its inverse and the determinant. So let's begin without any further ado. We'll be starting with explaining what is a matrices, as a whole, or what's a matrix. So because in the case anyone of you does not know, I'll draw a little bit. This is something to indicate like what is a matrix, and inside it you have your you have your numbers, your variables or whatever. So you will have it like this. So this is a matrix, and if I want to name it something, so I'll just put equal to, and I'll name it with some capital letters. So let's take, I name it A. So this is matrix A for us, right? So what will happen now if I have more? So this is actually a 2 by 2 matrix. 2 by 2 matrix. Because we have 2 rows and 2 columns, right? Also, in case you don't know, rows are, this is a row. It's a row. And when I look at this way, it's a column. Right, it's a column. So that's the difference between a row and a column. I hope that's clear as well. Now let's look ahead. Let's move forward. Look at another type of matrix which is different from this. It would be, let's suppose it's a matrix like this. I'll just write it first. It's got a, sorry, just a second. Yeah. So here we have a B, C, right? D, E, F, G, H, I. Now because in this matrix we have these rows and columns to be both are, so we have 3 rows and 3 columns, so it becomes a 3 by 3 matrix. Name it anything you wanna in the world. Let's name it X. So this will be what is X matrix, right? There is a way you can use it using your calculator as well, but we'll look at that in another video because it will be easier for you guys to use it, learn it using a video instead of learning it in this particular way. I cannot, do both things together because it'll be confusing then. So I'll just teach you the theoretical way today, and then I'll teach you the calculator way in the next video. Okay, continuing with this video. Hope you guys got a fair enough idea about it. Let's move forward to the inverse and determinants now. So guys, starting with matrix inverses, the first one or the first rule that you should know for the matrix inverses is gonna be that in multiplication you can see at that matrix A and matrix B, if they operate on each other they can create a different matrix, which is C. So A into matrix B will give you a totally different matrix, which is gonna be anything. Let's just say C for this case, but it could be anything different from A and B, of course. This is a B, so it gives you guys different matrices. I hope the first rule is here. It's very easy and understandable. Second rule that we have is that whenever we have operations A did to B, it can be undone. So like if I have multiplication, you can reverse it by division and you can undo it, right? But for matrices, you can also undo it by doing the inverse of the matrix. This is the undo type of a thing for this. And because inverse is undo, right? And usually written as A inverse is written like this. You can have B inverse as well, which will be written like this. And if the inverse exists, what you will do for that case, you will write this is a normal matrix A and this is the inverse of A, and when they two multiply, when A inverse and A multiply, you get I. Get an I, right? That's it. You need to know for this particular part. Let's move forward. Identity matrix is what I is. I did not talk about it because it was already mentioned and I want to talk about it later. So where I is the identity matrix, and also if I give you an example, if I take this two, or I would rather say instead of doing that, what we can do is we saw that AB can equal to C. These are totally different matrix. So we'll take out AB and we will write in A inverse C, which means that the B, after doing this, the next step for you guys would be removing this A inverse by putting an I, which is not a thing to put in the answer, so you can remove for the answer part, and this remains A inverse C. So that becomes, you remove the I from here. So there can be another step to be written over here, which is IB equals A inverse C. I'm sorry if you can't see me writing properly, but I'm just trying to explain it. I'm speaking so you can hear me at least. So IB equal to A inverse C, which will then equal to this as the final answer. You need to know that this I can be removed, but for that you will have to understand the concept first. And this I is only removed because we had this A inverse over here with this A, and then it got made into an I, which is irremovable, right? It is an identity matrix. So the usefulness of inverses became much more apparent solving. So it is when we solve more equations, solve more things, that's when you will understand how is this identity matrix used. So already talked about the inverse, or I would rather say I did not talk about the inverse in such detail, but I talked about the 2 by 2 matrix. So you guys know what a 2 by 2 matrix is, right? I told you it is something like this. Now, if I want to take out the inverse of a matrix, right? If I want to take out the inverse of a matrix, first of all, you will multiply these two. So, there are different methods you can use to find the matrix, if there is a matrix that inverse of that matrix. But I would say that the matrix, I would say the inverse matrix is 2 by 2 matrix A, where is A, B, C, D. We can make an equation out of that, which is this, right? Which is this. We can make this equation out of it totally. So this can be found, or I would say the inverse of A. So if I want to take out the inverse of A, that can be found by this method, if that's what my question says, right? So I can use this way to do that. Now what am I done here? First, for in the inverse, you just write it because you have to take that out. Then 1 is gonna stay here for all the time, for all the equations that you solve. Coming to this part, which is important. This is the multiplication of this with A with D and the B with C. So when you multiply these two with each other, you get AD, and then you subtract this one with this one. So if I name this one for just supposing it, I'll just, if I name this one X and this one Y, what you will do after that is you will subtract. So it will be X minus Y. Same thing they've done over here, except for they've not given me names, just written as it is. Then this, what you see right over here, which is this part, is just opposite, I would say. So what you do is for the X part, this part, A and D, you just reverse them. So if A and D is like this first, then it becomes like this later. Opposite, right? Then for the other one, you just change the sign. For the B and the C, you just change the sign. So from minus C and minus B, it was first only B and C. So you in mirror you change the sign. So for this one you change the sign, and for this one you just change the position, or you reverse the position of the particular wave. Right, and this is given, this equation is given in the data booklet, and you can easily use it over there. And yeah, that's all about to say. Now move forward to determinants. Right, so for determinant, let's start with the 2 by 2 matrix because that'll be easier. So what you will do for determinant? For determinant, you will simply take the DET from the determinant one and write determinant A. I'm sorry. Yeah, so you'll just take this DET and write this in front of the matrix name, so which is A here. Then you will take this one A into D and B into C and just subtract them as shown over here, right? Shown over here, subtract it. Then let me tell you, this is given in the booklet, IBDP booklet, and determinant can be written in another way as well. So, how? This is the vertical bars way how determinant can be written. So for matrix, we normally put bars, something which is like a little curved from the top and the bottom, like brackets, I would say. But for determinants, you can put vertical bars which are straight, right? It is straight, not curved. So determinant of A would be this. If I say something like this, it would mean determinant of B, right? So this would be determinant of A, which is particular, whatever the answer is. So if there is the same term showing up in the calculator while you inverse, right, for like a 2 by 2 matrix, you have to say that the determinant is 0 and the inverse does not exist. So if it is the same answer showing up, right, if I put this equation in the calculator and I get the same answer, if I get the same A, B, C, D back, that means it is going to be the same particular answer, and I'll say the determinant of the A will be 0 and hence inverse does not exist. This I'm talking about just the 2 by 2 matrix, which is something to show over here. So the 2 by 2 matrix I'm talking about. Right? So I hope you guys got a little bit idea about it. I will not be doing determinant of 3 by 3 matrix in this video. We'll look at that in another video. So we're done with what is matrices, what is the inverse of the matrices, and the determinant of at least 2 by 2 matrices. We are yet not done with the 3 by 3. We'll look at that in another video. Only 2 by 2 is done in this video because I want to look at that in a little more depth, as it is a little bit of a more trickier part of the determinants. So I hope you guys enjoyed the video. If you did, please don't forget to show a thumbs up, like the video. Also comment if you have any doubts, any questions, any queries, or anything related to the video. You can also comment how you like the video or not. And if any improvements you want, whatever the thing is, just comment down and I would like to read it and I would love to improve on that. So if you are liking my videos, don't forget to subscribe to my channel because that's will help you to that will help you see more of my videos and I will show you guys, I will get you more of my videos. So yeah, and do subscribe if you like my videos. Thank you. Bye bye and have a really nice day.